My next task is to streamline the fluttering of the leaves. If I press play, they look okay from here, but that's only if the wind is blowing extremely strong all the time. I might want the wind to really slow down a little bit. And so using a randomized value by range node driving the angle that I've got from the closest location on geometry is really not the way to go here. I really just wanted this to generate a single random value to kind of fill out the tree leaves and give them a little bit of more volume. So I'm going to actually turn off the animated flag, and I'm going to actually allow for a greater min-max range now. And if I set the timeline to frame 2 again, I can see those changes propagating. So I'm getting 360-degree range of randomization. Now what I'm actually going to do is randomize a value around a cone angle. What I want to do is use the y-axis of these particles. If you remember, on the ground, if I can find it, there it is. We have our original object. And if I look at its local y-axis, it points up the top of the leaf. So if we use the local y-axis as a pivot point, we could then add like a directional spread of turbulized rotation to the particle, giving the leaf a fluttering motion. So let's look at doing that. If we look up any tool that possesses the ability to rotate around a cone, you can see that I have a user compound called Turbulize rotation by cone, my little U designating the compound there. But there is a randomized rotation by cone that you can use to build your own. So I'll actually show you how to do this. All we need to do is pull in a randomized rotation by cone, and if we look at it, it has a cone axis that we can choose. So in our case, the positive local y-axis, and then we can choose values to twist around the axis. So this is giving us the fluttering motion, the twist, min, and max, and the start and end angles that allow us to do it, and whether or not the effect is animated over time. So these are just smoothed rather than randomized if we make the changes. So I'm going to dive into the randomized rotation compound, and everywhere I see a randomized value by range, I'm going to replace it. So I'm going to do that by finding a turbulized value by range, the close cousin, and make sure that I hook the exposed inputs from the compound to this turbulized value by range rather than the randomize. So right away I know that I need to take the twist min-max. Of course I do get a pass-through node, which are usually added for me automatically, so I'll leave those up here. I'll move them down momentarily. I then need to gather the animated Boolean that has been controlled by a pass-through. So I'll plug that into my Turbulize value by range compound. Move that back. And finally, I need the random seed coming from the add node. And I'll plug that into my random seed. So from there, I can actually delete this randomized value by range, not before plugging the value of the turbulized value by range compound into the angle of the axis and angle, thereby making this one moot. I do not need it. Okay, so the same thing's going to happen for the other ones, which sit a little bit lower. If I go down to the next group, so this one rotates the perpendicular vector around the cone axis randomly. So this is the one that's going to get us this nice smooth motion that we want. So we don't want a real random vector, we want a real turbulized vector. So let's look at what we need to replace here. We only need to replace the seed. So I'll bring in another turbulized value by range and the animated flag as well. So we'll pass those through. And if I double click on the randomized value by range, I get a min-max of negative 180 to positive 180, so a full 360-degree end vector. let's go with negative 180 and positive 180. I also have the benefit of a turbulence scale on top of this, as well as speed and complexity. So I have far greater control now than I did with the randomized value by range. I'll again make sure I know what the randomized value by range was connected to. And finally end off with this last one here. Notice this last randomized value by range for its min-max is using the start and end angle exposed inputs. So I'll pull this down. I'll get the start angle, min, end angle, max, and again we get these pass-throughs. So I'll pull them down. And I also need to deal with the animated and seed flags again. So this one here, and our animated flag as well. There it is. We'll make sure that points out to the same axis and angle to rotation, and I believe that's everything. We have 4 connections. So we've just replaced the randomized value by cone with a Turbulize. I'll just rename this. And we can now export it. And when we export it, just to show you here, it'll export into tasks modifiers as well as deformation modifiers. So you would be able to find it under particle tasks modifiers. Again, you can see the randomized rotation by cone here and the Turbulize rotation by cone I saved earlier. So you can just export that compound, overwrite the one I have there. And we're back in business. So now that this outputs a rotation, I can add it back into the equation here. So I'll add that back in. I'll open up the Turbulize rotation by cone. If I zoom back out to my tree, I should be able to start adding some values to this now. The cone axis should be the y-axis. Let's just put this on loop. And I'll start working some of these values. So let's go with negative 180. And positive 180. See what's going on here. I'm using the y-axis. I'm turbulizing the rotation by cone. Something must be disconnected in here. I'm thinking it's the animation speed. If I look in each of these Turbulize value by range, I have a very low turbulence scale and a very low animation speed. So that's likely the culprit. I'm guessing I might have to expose these. So let's see. If I did an expose input for turbulence scale on all 3, as well as animation speed, let's just do this in order. I'll be giving myself a way to ramp up the performance a little bit. So let's try that now. There we go. So that's all we were really missing, was that Turbulize values use a scale over time, and they also animate the speed of that same scale over time as well. So you have a number of factors you can control. So my goal here is just to find the optimal angle for these leaves to blow at, but notice how that they smoothly rotate over time now, which is exactly what I wanted. So I'll just play with these angles a little bit. I think for the twisting angles, we probably don't want a full 360 degrees. I'm guessing I might clamp that. Yeah, it's actually not looking too bad. I could always link the turbulence scales together, but at least now I'm getting movement through the leaves and I can control the speed in whatever way I want. If I wanted to increase the frequency, I can also decrease the turbulence scale or increase it to get a more lulling breeze over time. Awesome. So we've gone in and we've extended our favorite rotation tool for dealing with instance particles.